This is Subsequence, and we're going to try and solve this with minimum complexities of on time and o1 space. Now, our problem statement gives us two strings, s and t. And what we're being asked to do is determine whether string s is a subsequence of string t. A subsequence is obtained by deleting some characters from the original string without changing the order of the remaining characters. So, for example, take a look at the problem statement where it shows you ACE, A-C-E, and A-B-C-D-E. In the example, ACE is a subsequence of A-B-C-D-E, and ACE is a subsequence of A-B-C-D-E because we can obtain the ACE word by deleting characters B and D from A-B-C-D-E. So, I hope that that's clear, and you can understand why ACE is a subsequence of A-B-C-D-E, while AEC is not, because those characters are not in the same order. Now, your options for an optimal solution to this problem are A. Linear search, B. Two pointers, C. Sorting plus binary search, or D. Dynamic programming. I'm going to pause for a few seconds while you think about this choice. So, for those of you who are able to get it, congratulations. And for those of you who just want to see the code, the answer here is B, two pointers. Now, let's discuss the brute force approach. In our application, we provide a rudimentary brute force, and we can just generate all possible subsequences of T and check if they match S. Obviously, this is not a very wise approach, and personally I wouldn't use even a brute force for this problem in a real interview situation. I think it's a little bit easier than that. But in any case, you have something that you can choose to work with. In our optimized solution, we use the two pointers technique to solve this more efficiently. We use pointer 1 and pointer 2 to traverse the strings S and T respectively. We check if the characters at the corresponding pointers match, and then move them accordingly if necessary. After we've iterated through the strings, if all characters in S are found in the same order in T, the function will return true. Otherwise, it's going to return false. And our return here is that count equals s.size. You can see we've got a count variable. Now, let's go through this line by line so we can really check understanding here. First of all, we've got pointer 1 initialized to 0, which represents the starting position in string S. Pointer 2 is also initialized to the same. It's the starting position in string T. Both of these will represent the current position of the index in their respective strings. Count is initialized to 0, and this will represent the number of matching characters found in S and T. And as you already know, we're eventually looking to return the count being equal to s.size. If it's true, we're returning true. Otherwise, we're returning false. Either way, we should be returning the correct answer. Our while loop will continue for as long as both pointer 1 and pointer 2 are within the bounds of their respective strings. The first thing we're checking is, well, it's the only thing we're checking within the while loop, is the character at pointer 1 in S equal to the character at pointer 2 in T? If we found a match, then we're going to jump into this section. First of all, we're going to increment the count of matching characters, and then move the pointer pointer 1 in S and the pointer 2 in T to their next positions. Otherwise, if the characters don't match, we're simply going to move the pointer in T to the next position. And we'll be looking at the same character in the S string and finding if it has a match in the T string. Anyway, after we've gone through all of that and exited the while loop, we'll be checking if the count of matching characters is equal to the size of the S string, or the length of that string. If it does, then we're going to return true, otherwise return false. So that's it. And I hope that that's clear enough. So that's one more problem solving session completed with Coding Card Sharp, where we've used one of these 4 techniques to help solve the isSubsequence problem. And you should already know it's the 2 pointers technique. There's quite a long explanation why, with a few more details about the complexities here. Now, if you prefer to learn just by reviewing and reading code, we have this in C++, Python, and Java within our application. And if you're still struggling with, well, problem solving in general, and critical thinking especially, I would strongly recommend this course, in which Dr. Ibrahim places a heavy emphasis on improving your critical thinking skills and especially problem solving ability. Anyway, in our application we're done for this problem. The next one we'll be doing within our course is the isomorphic strings problem. Thank you for watching.